This is section 8.2, Law of Sines. So law of sines is going to apply when we have an oblique triangle, which is when you don't have a right angle. They can have all acute angles or one obtuse and two acute angles. And when we have this, you're going to have like the sine of A, which is when you're going to have an angle over the side of A. And notice, and what we should have here, there should be an A right there. Notice A, the angle is opposite from side A. And same thing, your sine of B is opposite from side of lowercase b. And same thing with sine of C is opposite from side C. And all of your angles should add up to be 180 degrees. Now, you're going to set these equal, like one of these could be set equal. These are ratios. So one could be equal to another, and we'll use any pairing could be set equal to another one. So we use this when we have angle, side angle, or side angle, angle. We can also use this for side, side angle, and we'll get to that on example 2. But when we get to that, we have to check and see we could have the possibility of no triangle, one triangle, or two triangles, and I'll show you how to check for that. So on our first example, we have angle A, angle C, and side A. So this is actually an example of side angle, angle. And when we set this up, we can see that we have an angle and a side, so angle A and side A. And so when we set this up, we'll zoom in here a little bit. We would have the sine of 50 degrees over 3. And we can start off by solving for side C. So we can do the sine of 20 over side C. And what I'm going to do is I'm going to cross multiply. So if I cross multiply, I'll have C times the sine of 50 equals 3 times the sine of 20. And if I'm going to solve for C, what I'll do is I'm going to divide by the sine of 50. And so C is going to equal, and so we can type this into Desmos. And when you do this, if I click off this here, if you see this little wrench up here, you do want to make sure that the degrees is highlighted. You want to make sure you're in degree mode. So now what I'm going to do is I'm going to type in 3 sine of 20. And you want to make sure that you're out of that 20 there, so you're not dividing a sine within a sine, divided by the sine of 50. And it tells us to round to 3 decimal places, so C is going to be 1.339. Okay, so now we need to find B, angle B, and side B. Now we can find side B because we can do 180 minus 50 minus 20, and that's going to give us 110 degrees. Okay, and I'm going to use this ratio again. I'm going to set up sine of 50 over 3. I'm going to use that again. And sine of 110 over B, because 110 and B, that's what goes together. So if I cross multiply again, I know that B equals 3 times sine of 110 degrees over sine of 50. Because I know when I cross multiply, I know I'm going to end up dividing by sine of 50. So again, if I go to Desmos, actually I can just change my 20 up here to the 110, and I'll get 3.680. And there are my 3 missing pieces to the triangle. All right, so on my next one, I'm given, so this pattern, if I look up here, and if I were to fill in, like, here would be my 70, here would be my 60, and C would be 4. So I can see that this pattern is angle, side, angle. And if I go ahead and solve for C first, I could do 180 minus 70 minus 60, and I would get 50 degrees for C. All right, so what I do have to start off with is I can set up sine of 50 over 4 because I have the C, I have my C's, and I'm going to find A first. So sine of 70 degrees over A. So A is going to equal, if I cross multiply to get that 4 times sine of 70 over sine of 50. So if again I go to Desmos, I have my 4 times my sine of 70. Make sure you get out of that parentheses, divided by the sine. Oops, I forgot my division there. Well, it didn't move that to the bottom. Divided by sine of 50, and we will get 4.907. Okay. And again, I'm still going to use sine of 50 over 4 to find B. And I got to use 60 degrees for B. So B is going to equal 4 times sine of 60, because I'm just multiplying those two, divided by sine of 50. So if I go back to Desmos, I can just change the 70 to a 60, and I'll get 4.522. So there are my 3 parts to that one. Okay, so now what happens on these, if I go and erase these, B is 4, C is 3, and capital B is 40 degrees. So this is a situation where we have side-side angle. And this is a situation where either one triangle exists, a possibility of 2 triangles exist, or no triangle exists at all. And that is because these 2 sides, the 4 and the 3, that angle can actually adjust and be bigger or smaller because like it's not set, like we don't know because of we don't know what C is. With the way that the other angles are, like when we know what 2 angles are, that means that the given side has to be a certain length. Or like whenever we do know that what 2 angles are, or even if we know a side in between 2 angles, it means that we definitely have one triangle. And one easy way to remember this is if we write this going the other way in reverse order, you're going to write a bad order on your paper. And so when you learned about this in Math 2, we always said you can't have a triangle like ASS doesn't make a triangle. Well, now we're learning that you actually can, there is a possibility you can have triangles, and in fact, you can have 2 triangles. So we're going to look at this. So the first thing that we're going to do is we are going to find side C for this, or yeah, we're going to find side C. So we're going to do the sine of 40 over 4. Not the side of C, sorry, the angle of C. Sine C over 3. So what I'm going to do is I'm going to take this 3 and I'm going to move it over here. So it's going to look like this. So 3 sine of 40 over 4 equals sine of C. Now, when we type this into Desmos, what it's going to look like is we're going to do the inverse. Anytime you're looking for an angle, you always do the inverse. So we're going to type it in like this into Desmos. Okay, we're going to use the inverse sign. And again, make sure you're in degree mode, which is not going to change. So we're going to do the inverse sign, and we're just going to do 3, and then it's a regular sine of 40, and then make sure you get out of that parentheses. Notice where my cursor is, and then divide by 4. Okay? Now, my angle here is 28.822 degrees. Okay? So this is C. So we know for sure that we have one triangle. If it wasn't going to be a triangle, we would get an error message right here. So we know for sure we have one triangle. Now from here, I'm going to check for 2 triangles. So to check for 2 triangles, I'm going to do 180 minus 28.822. And when I do that, I get 151.178. Now, if I get 2 triangles, that is going to be my second C. And I would go back and label this C1. So to test if this actually works, I take 151.178 and I add it to the 40 degrees. I'm adding it to this 40 degrees right here. And that gives me 191.178. Now that's a problem because when I added that, this is just 2 angles. This is my second C and that's my B for my original triangle. Well, these 2 angles are bigger than 180 degrees. So 2 angles in a triangle are bigger than 180 degrees, and 180 degrees is what makes up 3 angles in a triangle. So that's not going to work. So I only have 1 triangle. So this isn't going to work. I only have 1 triangle. So I only have 1 C, so I can just proceed with finding my normal pieces of my triangle. So I'm going to go up here, and I'm going to finish, and I'm just going to do 180 minus the 28.822 minus my original 40, and I'll get 111.178 degrees. And so that's going to be angle A. And now I'm going to I have to find side A. So I go back and I use that sine of 40 over 4. And I'll do sine of the 111.178 over A. And so remember when we did this, we'll just do A equals 4 times the sine of 111.178 over sine of 40. And so A is going to equal, and so that's where we'll just go back to Desmos, and we'll type that in. So 4, And now I'm not looking for an angle, so I'm just back to using regular sine. So sine of 111.178. Make sure you get out of that parentheses, divided by sine of 40. And I get 5.803. Okay. So on our next one. So again, if I look at this, I can see what pattern it's forming here. So little a is 3, B is 7, and my angle is 70. So I can see again that that is side-side angle. So if I take sine of 70 over 3, I have to find B first. That's the only option I have, okay? So if I take the 7 and I move it up and over here, I have 7 times sine of 70 over 3 equals the sine of B. And since I'm looking for the angle, what I'm going to type in is the inverse sine of 7 times sine of 70 degrees divided by 3. So it's going to look like this on Desmos. So I do inverse sine 7 times regular sine of 70, go outside that parentheses, and then divide by 3. And notice it says undefined. That means this cannot form a triangle. Because what that means, well, let's go ahead and write our answer down. Not a triangle, and so we're done with this one. But what that means happened here, this angle is too big or this angle can't happen with a side of this size and a side of this size. It can't happen. It's not going to work for that. Okay, so now let's look at this one. You can probably guess what's going to happen on this one because we've had one triangle so far. We've had no triangle so far, so you can probably guess we're going to get 2 triangles on this one. Okay, so when we set this one up, we've got our pairing here, the big B and little b. So we've got sine of 40 over 2. We have to find the angle C first. So if I move my 3 to the other side, I'll have 3 sine of 40 over 2 equals sine of C, which means I'm going to do inverse sine of 3 times sine of 40 divided by 2. Okay, so if I just change up my numbers here, I have 3 times sine of 40 divided by 2. So I get 74.619. Degrees. So this is C. Now, if I check for 2 triangles, we'll do 180 minus 74.619. We get 105.381 degrees. So I'm going to go ahead and label it as C2. So then if I do 105.381 plus 40, we get 145.381 degrees, which this is less than 180 degrees, which means we do have two triangles on this one. So I can go ahead and box this as C2, and I'm going to go back up here, and I'm going to put a little 1 right there because I got two triangles. Now, since I'm already on C2, I'm going to go ahead and finish out my second triangle. Now, this 105 plus 40 is 145 here. Those were those two angles added up together. So if I just do 180 minus this 145.381, that gives me 34.619. That is my third angle. So that's my A2. Okay? Or you could go back and do 180 minus 105.381 minus 40. That would also give you 34.619. So those are my two angles for that second triangle. I also need to find the third side. Okay, now both of these triangles are going to share the given information. So B equals 2, C equals 3, and big B equals 40. That is shared. That information is the same for both triangles. What is going to be different is the little a, side A, and then angle A, angle C, and side A. So next we're going to find side A. So I'm going to do sine of 40 over 2. Now I already used that once, but remember I said that is the same for both triangles. Equals the sine of 34.619 over A2. And so A2 is going to equal 2 times sine of 34.619 divided by sine of 40. All right, and when I type that in, A2 is going to equal 1.768. So there's my information for my second triangle. So if I go back and find everything for my first triangle, I can do 180 minus the 74.619 minus 40. So that's going to give me 65.381 degrees. That's angle A1. And then if I do sine of 40 over 2, because remember that's the same for both triangles, equals sine of 65.381 over A1. I don't know what happened there. So then A1 equals 2 times, I don't know why that keeps happening. Sine of 65.381 divided by sine of 40. All right, so when I type all that in, A1 is going to equal 2.829. So it's very, very important to label everything. All right, so that concludes law of sines.